Welcome back. In this task, we will calculate the measure of frequency metrics of a column in a dataset. We will calculate the total number of values, total number of unique categories, and frequency of occurrences in each unique category in a column. In an R data frame, each column contains values of one variable, and each row contains one set of entries from each column. When loading a new dataset, you should first investigate the total number of values in each column. In our example, let's pick a column transmission type from a dataset, variable data, using the dollar symbol. Type the following line of code and execute it. You will see the output is 11,914. The length function returns the length of a column, that is, the number of values in the column. Imagine if the sender of this data told you the dataset contains information on 11,920 cars. This metric would have caught that anomaly in the dataset, that is, missing information for 6 cars. Next, you should investigate the number of unique categories in this column. Type the following line of code and execute it. This command is a slight modification of a previous command. Here you have chained two commands together. First, you are finding the unique number of values in this transmission type column, and then you're finding the length of that unique categories. This will give you an answer of 5, saying there are 5 different transmission types in this dataset. This metric is useful as any unexpected entry can be identified at an early stage. Lastly, you should know the distribution of values within each category. In your case, it's the distribution of number of cars that belong to each type of transmission category. In R, you can use the table function for this purpose. This function calculates the frequency distribution of each unique category in a column. Type the following line of code and execute it. The output is the categories arranged in alphabetical order and their associated frequencies. Usually you would prefer the output to be in ascending or descending order based on frequency. Let's store the output in a variable. And you can store the result and pass it to a sort function. Type the following line of code and execute it. To view the output, you can just call the variable. Now you can see the output is arranged in decreasing order based on frequency. So you have 8,266 cars with automatic transmission, 2,935 with manual, and so on. Now let's practice. Pause your video to try this out yourself. Great job on completing the second part of this project. In this task, we learned about how to calculate measure of frequency metrics on a real-world dataset column and how it can help you in identifying errors in your dataset. In the next task, we'll pick up where we left off here and we will calculate the measure of central tendency metrics of a column in a dataset.